Hello and welcome back. In this video, I'm going to be focusing on access control specifiers. So we have three access control specifiers in C++: private, protected, and public. Now I have got a class MyBase here, and a little further down, I have another class called MyDir, which derives from the MyBase class. All right, so let's look at the MyBase class first. By default, if you do not specify an access control specifier, access is private. So this variable base PVT is a private variable, a private member variable. Next, I have the protected access control specifier, which now um, says that base prot is a protected variable. Similarly, once you specify public, all that follows the public specifier are part of the public interface of the class. So base pub is a public member variable, and you have the MyBase default constructor and the parameterized constructor, as well as a display function. So let's take a look at the display function and what have we got here. So the private variable, the protected variable, and the public member variable, all these are accessible within the class, and that's what is shown here. So the display member function has access to all these three types of variables. So that's pretty straightforward. Now let's look at the MyDir class. Now the MyDir class derives publicly from MyBase. It's got its own private variable. It also has a public interface. And in the public interface, you got dirpub, which is a public member variable, and you also have the constructor for MyDir. This in turn calls the MyBase constructor, and it also initializes the two member variables which are specific to the MyDir class. All right, now there's a display function for MyDir as well. And let's take a look at that. So you have the base PVT variable. So any MIDR object is going to contain a sub-object. The sub-object is going to be a MyBase sub-object. So MIDR has uh, access to only certain portions. So MIDR's member functions have access only to certain um, parts of a MyBase object. So the base PVT member variable is not accessible outside the MyBase class because it's a private member variable. But since this is a derived class and it's derived from MyBase, it has access to the protected variable. So base prot is accessible within the derived class, and that's the reason why we have protected member variables. If you want a variable to be accessible only to your derived classes, but you do not want it to be accessible anywhere else, that's when you use a protected access control specifier. So let me repeat that: only when you need your derived classes to have access to member variables, you would use a protected access control specifier. If you do not want anybody to access your member variables, you put it under the private section. So here base prot is a protected member variable, and of course base pub is a part of the public interface of MyBase, so that's available. And dir pvt and dir pub are member variables of the MyDir class, so they obviously will be available and accessible within this display function. So that's um, uh, the way the MyDir class has been laid out. Now let me also touch upon another important concept. So I've declared a friend function here, and this friend function is a friend of the MyDir class. Now, friend functions have access to private variables, right? So, private variables of the class for which they are a friend. So, in this case, this function, friend of MyDir, is a friend function, a friend of the MyDir class. Let's look at how that's been implemented and what I can access within this friend function. So, as you can see, this friend function takes a reference to an object of type MyDir. Now we know that a MyDir object contains a MyBase subobject. So yeah, it's obvious that it can access the dir pvt and dir pub variables. But can you access the private variable of MyBase? No, because private variables of MyBase are not accessible outside the MyBase class. But you can access the protected variable and you can access the public variable. Of course, you're using a reference to the MIDER object. So using a reference to the MIDER object, you can still access the protected as well as the public parts of the base object. Now, this is because this is a friend function of the MIDER class. So protected members are accessible within the derived class, that's MIDER, and also friend functions of the derived class. Now there's one small quirk. If I change this to my base, what happens? Obviously, my base doesn't have any knowledge about PVT and pub, so that makes sense. But why does the compiler signal this as an error? After all, base prot is a member of the MyBase object, and you're passing a reference to the MyBase object. So why is this showing up as an error? That's because this breaks the whole protected access control setup, and C++ doesn't want that to happen. So there's a C++ rule which says that a protected member can be accessed only using a reference or a pointer to an object of type MIDER or an object of the derived class. So it's only through that derived object that you can access the protected member. You cannot directly access the protected member using a reference to the base class, because that would completely break why we have a protected member. If you're going to be able to use an object of type MyBase and access the protected member, then there is no point in having that protected access control specifier. So this is something to bear in mind. And let me move further down. Now, all that I've explained to you, I have put into action here in our main function. So I've created an object of type myB and I'm calling the display function. And now you must remember that myB, this is an object that's available. I mean, users of the MyBase class are going to be instantiating an object of type myB. So this is not really going to give a person or give the user access to the private or protected portions of the MyBase object. So that's the reason if I uncomment out this line, the compiler once again marks this as an error. That's because the protected members are not available to clients of the MyBase class. They're available only to the derived class and friends of the derived class. So that's why you cannot directly access, a client of this class cannot directly access the protected members. Of course, they can access the public interface. So the public members here are base pub and the display function. So I'm modifying the base pub here and I'm also calling the display function after that. So well, why don't we run the program now and see what happens? So let me just comment out this portion. Yeah, so let me comment out all that code. So we're going to be running only this simple MyBase portion. Okay, and let me run the code. Okay, so as you can see here, the very first time MyBase has been initialized, right? MyB is an object which has the values 23, 24, and 25. So that's shown up here. And then I modify the base pump to 101. And then I call display again. So let's see whether that has happened. 23, 24, and base pump is 101. So that's what we expected. Excellent. So let me now comment out this portion, so we don't no longer need that. And let me uncomment all this. Okay, so what am I doing here? I got my the object being set up here. So it takes the values 33, 34, 35, 36, and 37, and I call a MyD.display. So let's try that first. Let's go step by step. So as you can see here, 33, 34, 35. So I'm able to call MyD.display, and as you can see, MyD.display can, um, okay, it's here. So it obviously it cannot access the private member variable of the base class, but other than that, it can access everything else. So it can access the base prot, the base pub, the dir pvt, and the dir pub. And that corresponds with the values that we have initialized 34, 35, 36, and 37. So now let's remove this comment. And what have I done here? So I'm actually modifying the dir pub, and I'm also modifying the base pub, and then I'm calling myD.display again. So let me comment out this portion of the code, and oops, okay, let me run it again. So as you can see, I have modified dir pub to 200 and base pub to 300. So you have dir pub at 200 and base pub at 300. Those are the values that we expect. Excellent. So let me now look at the final portion of the code. Let me uncomment out all this. So as I keep saying, you cannot access the private member variable of the base class outside the class. That's why it's flagged as an error. And once again, the protected member variable, this cannot be accessed or cannot be used by clients of the class. So the protected member variable, as I said, can be only accessed within a derived class or by a friend of the derived class. You cannot access it like this. So clients of the derived class cannot access a protected member variable. So that's why the compiler once again flags an error. So let's comment this one out as well. And once again, the PVT is a private member variable of the derived class. Now clients of the derived class cannot access private members. A private member can be accessed only within the class, right? So that's what we see here. So you can only access it within the class. So that's why that is also showing up as an error. So let's comment that out. And I finally call my friend of MIDR, uh, the friend function. So let's recap what's there within the friend function. The friend function, as I said, it can access, yeah, let me uncomment out this. It can access private members of the class for which it is a friend. So in this case, it can access dir pvt, and obviously it can access anything that's in the public interface. So dir pub, and it cannot access the private member of the base class. That goes without saying, but it can access the protected member variable, and it can access the public member variable of the base class. And to recap, you have to use an object of type derived, right? So you should use an object which is of the derived class type. You cannot use the base class type to access the protected member variable. That kind of breaks the whole abstraction. So that's the friend class, and that's what I've called here. So let's maybe comment out this. We don't need all this. Have I given him enough comments? Yes. So we don't need. Okay, let's call the display. Let's run this. So as you can see here, I have 34, 300, 36, and 200. So that's this. So I've changed my dir pub to 200 and my base pub to 300. So that's what is expected. And then I call my friend. So what does the friend do? Dir pvt is 36. Yes. Dirpub is 200. Yes. Base prot is 34. Yeah. And base pub is 300. So that's all good. Let me complete this. Now, one thing you need to bear in mind is that you have a class here which is publicly derived from MyBase. So what happens is when you publicly derive from MyBase, all the private members of MyBase are still private in MIDR. All the protected members of MyBase are protected in MIDR, and the public members are public in MIDR. So any user of MIDR has to bear that in mind when they're writing code to access any of the members of MIDR. Now, you also have protected inheritance. So this is the derivation access specifier. So I'm deriving MIDR as a subclass of my base, but I'm using protected derivation. Now, if I do that, so by default, most of us, for most of the use cases, we use public derivation. So like MIDR is of type MyBase, but you can also do this, or you can also do this. All right. So now if I do this, if I derive MIDR privately from MyBase, what does that mean? It just means that everything that's here in MyBase becomes private in MIDR. And similarly, if I derive using the protected derivation access specifier, this would mean that the private remains private, obviously in MIDR, and the protected remains protected, and the public members of MyBase also end up as protected in MIDR. So any user of MIDR has to bear that in mind. So these derivation access specifiers are useful for users of the derived class. All right. And these access specifiers that you see within this class, right? So you got private here by default, protected, public. Now these access specifiers control what can be accessed from MIDR, what of MyBase can be accessed within MIDR. These derivation access specifiers have to be used by users of MIDR, have to be taken into consideration by users of MIDR. I know this is a little um, confusing and it could be a little too involved. So to start off, just go with using public derivation. And if you have any questions about private or protected derivation, um, please feel free to send me a question and I'll be happy to answer. And this code is going to be available on my repository, so you should be able to play around with this code and get more familiar with the concepts as you practice them. So play around with this, and this is quite an important topic. So I would suggest that you take a look at this code and then make some changes, try it out for yourself. Thank you, and I'll see you in the next video.